In this video, I'll show you how to create a line chart animation where both the x-axis and the y-axis are transitioning, as well as the line graph. I'll also show you how to create an animation where only one of the axes, in this case the x-axis, is transitioning or animating, and the line chart reacts to that, whereas the y-axis remains static. We'll also create an area chart that transitions along with the x-axis. Let's look at the setup. We have our D3 dependencies, our index.html file. We have jQuery dependencies to read the CSV. We have our main.js file. And we have the sample data, which has two columns, a date column and a value column, which we'll use to create both line and area chart, and around 1822 rows of data. So let's start on our index.html file. So we'll just write the boilerplate, give it a title, add a div element. This is the element that will contain our SVG. Give it an ID. And let's add all the dependencies, which is our D3 dependencies, as well as the jQuery to read the CSV, and our main script file. We'll also quickly go and add some styles right in our index.html, just to target our div element as well as the body element. So with that out of the way, let's start. Let's create two variables, sample and an empty array to hold our CSV data. We'll give our SVG element some dimensions. We haven't created the element yet, but we'll add the dimensions first: width, height, and some margin. 50. Let's create the SVG element first. So we'll select a div element with the ID, and then we'll append the SVG. And then we'll add the attributes. So let's first read the CSV. So we'll use the fetch, and this is where the jQuery dependencies come handy. So we'll fetch the CSV first. And then we'll use the promises to read the CSV. Once we get the response, we'll convert it into text. And then we'll read the data. And we'll use the jQuery here to basically convert the data to an array. And I'll show you how the data looks as it is read from the CSV. So if we print that out and I inspect it, so let's there's some error here. It's a syntax error. Okay, yep, I can see I made a mistake there. Okay, so this is what we're getting at the moment. We're getting an array of arrays. So like a two-dimensional array, there is an array of arrays. This is not what we want. We actually, to make our life easy, we actually want to create an array of objects. So we'll just create a function, and we'll iterate over the sample array, and then read each element from the sample array, which is an array itself. And while we're doing that, we'll grab hold of the date and the value from each of that array and add it to our own object. And we'll do that by saying data.push. We'll create the object with two properties, date, and we'll also format it by using d3.timePass, %y, month, and day, and the date is at the index 0. And we'll repeat the same for the value, and we'll add it to the attribute price. And that value is at index 1. And I can quickly show you, because we got the array of arrays, so that's where the date is 0 at index 0 and the value at index 1. Okay, and if we just print that out now, so let's copy that. Let's call the method. And let's print that out here. And this time we get the array of objects, and which is what we originally wanted. Let's create the x-axis. Now we got hold of our data. So we'll put the time, the date on the x-axis and the price on the y-axis. So we'll create scale x, and we use scale time dot domain data, and we use d3.extend to get the extreme values of the date, and we'll return d.date.nice, and then we'll give it a range. So we want to plot it from dim.margin, which is 50 pixels, to dim.width, which is 1000 minus 50. So we want to plot it from left to right. So that constructs our scale. Okay, so let's now look at creating the axis. So let axis x. So we'll append the axis to a group. And we'll give it a transform attribute. And we'll just translate it to the bottom of the screen, because the axis originally will be painted or drawn at the top of the screen. So we'll just translate it to the bottom, because D3 constructs everything from the top left corner. So that's the reason we are translating. And then we'll add the axis by doing d3.axis bottom, and we'll add the scale x. So that's the code. And we'll use the same concept to draw the y-axis. In that case, we'll use a linear scale. So we'll say let scale y is equal to d3.scale linear. And I'll quickly write the code where everything else is same. So we're drawing the y-axis from the bottom of the screen to the top. Hence, we are going from dim.height minus dim.margin to dim.margin. So from the bottom of the screen to the top. But we have to translate it 50 pixels to the right, because the original place from where the y-axis will start to draw is at 0, 0. So hence we translate it 50 pixels to the right. Positioning the Svg elements can get pretty confusing, so it helps to visualize it. So we gave our Svg element a width of 1000 and the height of 1000, and then we gave it a margin of 50. So what we will want is our x-axis to be positioned in this blue rectangle at the bottom, and the y-axis to be positioned to the left of that in the blue area. So for that, if we focus on the x-axis, we gave it a range of dim.margin. So we want our x-axis to start not here, where it will originally start at the top left corner, but we want it to start 50 pixels to the right. So that's why we gave it a range of dim.margin, and we want the x-axis to go as far as this point. And for that, we gave the range from dim.margin 50 pixels to dim.width, which is 1000 minus 50, because this area is also 50. So hence we said start from 50 and go till 1000 minus 50. But D3 draws the elements from the top left corner, so it will have originally positioned the x-axis here, but that's not what we want. We want the x-axis to move down to this point, and for that we used did translate, and what we want is x-axis to be here. So for that, we don't want it to move in the x direction at all, so hence we gave it the translate x 0, but we want it to move in the y direction, and for that we gave it the translate from 1000 minus 50, and that's the x-axis position there. The y-axis works the same way. D3 will again try to draw the y-axis from the top left corner. But that's not what we want. We want our y-axis to be drawn from the bottom up. Hence, we gave it a range of dim.height minus dim.margin, which positions it here. So dim.height 1000 minus 50 brings it here. And then we want it to be drawn till dim.margin, which is 50. And that's where it will originally position the y-axis. And hence we use the translate function to move the y-axis in the x direction by 50. So this is where we position it, by moving it in the x direction. And that's where our x-axis and the y-axis are now positioned. So it helps sometimes to draw this and to visualize where we would like the elements to be positioned and how much translate and the ranges to use. Okay, with the x-axis and y-axis done, let's draw the line chart, and for that we'll use the D3 line generator. Let's create a variable line, and we'll use D3.line, which needs two attributes x and y, and for x we'll pass the date value from d.date to scale x, and for the y we'll pass the d.price value to scale y. And then we'll append our line by using path, and path requires a few attributes. We'll give it a fill of none, I'll give it a stroke, and we'll give it a stroke width 1 pixel, and path requires a D attribute, and for that we'll pass the line generator and our data. And with that done, our line chart is now ready. So to recap what we just did, we imported the CSV, we created scale X first by using d3.scale_time, and then we created scale Y by using d3.scale_linear. We used a line generator, and then we used the path to create the line. So once the line chart is ready, creating an area chart is also pretty straightforward. All we need to do is, rather than using a line generator, we use the area generator. And for that we say d3.area. The difference here is the area generator needs 3 attributes. An x attribute, same as the line chart, will pass the d.date value to scale x, and then the area generator needs y0 attribute, because area will be drawn from the scale x, so we'll just pass 0 to y1, which will be the actual value of the price. And I think everything else remains same. We'll just change the generator to area, and we'll give it a bit of a fill. And it's as easy to get the area chart after we know how to draw the line chart. So next task for us is how to animate these charts. So what we need to do is, at this stage we are passing all the data to the D3 at the same time and drawing the whole line chart and the area chart at once. So in order to animate, what we need to first figure out is to basically drip feed the data. Rather than passing the whole data array at the same time, what we need to do is we need to pass the data, we need to slice the data array and pass a bit of the data at once. So we need to pass, for example, first 100 elements and then the next 100 elements, and so on and so forth. So we can't pass the whole data array to D3 at the same time. So that's the first thing we need to figure out, how to slice the data array. The second thing we need to figure out is how to basically handle the drip feeding of this data. So for example, when the first set of 100 elements appear, we draw those elements, and when the next set of 100 elements appear, we may have to remove those previously drawn 100 elements, then redraw the next set of elements. And I think this is where D3's functionality really shines, where we can actually use the enter update and exit functions to let D3 handle the basically drawing of the new data points as well as removing the old data points or updating an existing data point. So what I'll do now is I'll quickly go and refactor the code, and then I'll meet you at the other end to basically run you through all the changes I've made in the code in order to animate a line chart. So animation's now ready. So rather than passing the whole data array at the same time, we are passing the data array one piece at a time. So to show you what we are drawing, we are passing 150 elements. We're taking those 150 elements out of the array and then passing it and drawing those 150 elements as a line chart. And then we're keeping track of the length of the array, and as we're getting to the last part of the array, we're passing the last 22 elements left, and then we stop. So we made a few changes to our original code. The first thing we want to do is we want to slice the data array and only submit a part of the data array to be drawn as a line chart. And for that, I created a new function within our convert to array function. I created a new function, and it iterates through the array and submits 150 elements to be drawn at one point in time. And to control that, I'm using this setInterval method. So the setInterval method calls the sendDraw method every 1 second, and the sendDraw method calls the draw function, and I'll show you the draw function in a second. It calls the draw function with the 150 elements from the array, and once that interval is passed, it calls the next 150 elements and sends this over to the draw function. After that, we're creating the axis as we created previously. This time we are axis X is calling, so pretty much similar to what we did before, but I've taken the axis out of the draw function. We're still using the line generators. I've just left the code for the area generator there, but we can just ignore that. And then when the draw function is called, it updates the scale X, because both the scale X and the scale Y, as well as the line itself, needs to be updated in transition. So it updates the scale X, it updates the scale Y, and it then calls the update data method. So this is the data which is, for example, 150 elements. The first 150 elements are received here. And then we use D3's join method to enter, update, and exit the 150 elements. So when the first 150 elements from the array are sent to this method, they are drawn by this append function or the enter function here. And once those the next 150 elements appear, the previous 150 elements are then taken care by this exit function. So if you understand basics of D3, so that's like the core functionality of D3. So when the elements appear on the are sent to the enter function, they're drawn. When the new elements appear and the previous elements are removed, they are just removed by the exit function, and that's what's happening here. So hence our 150 elements you could see on the animation were getting drawn, and when the next 150 elements are appearing, those next 150 elements had different date values. So if I show you the CSV, so for example, let's say we are only sending around 10 elements. So the first 10 elements have different date values. So when the next 10 elements are sent over, the first 10 elements are no longer required, and hence the exit function takes care of them and removes them and then draws the next 10 elements. And to facilitate that, when we are actually passing the data, we are also passing the d.date method, d.date value to it, because that's our unique identifier. That's how D3 knows that the next set of 150 dates that are passed are not the previous 150 dates. So hence it removes the previous dates and draws the new dates. So here I've slowed down the animation considerably, and you can see how when the set of elements are passed to the draw function, how it is removing the previous line graph, updating both the x-axis and the y-axis, and then drawing the new line chart. And to make it concrete, this is how we originally created a line chart. We sent the whole array and we drew the x-axis and the y-axis and the line chart at the same time. We didn't send it to the draw function, but the concept was the same. And with the refactoring, we sent a part of the array first to the draw function and use the enter, update, and exit functions to draw that part as a line chart. Then we sent the next part and we repeated the process till we got to the end of the array. So by controlling what we send to the draw function, we can control the type of animation. For example, if we want to see a longer term trend, we can append the next set of array elements to the existing elements. So previously we were sending 150 elements at a point in time. What we can actually do is we can keep the 150 elements. So we start with 150 elements, then we send in the next round, we send 300 elements. So we're not removing the previous 150 elements. And in the next round, we send 450 elements. In that way, we can get kind of a good historical long-term trend of the animation. So you can play around with this and come up with your own different types of animations. So to get the long-term trend, all I need to change is change the var1 to 0, and that way for each interval it starts with the previous elements that have already been appended, and then it sends the next set of 150 elements from the start of the array. So that's how we get the longer term trend. Also, we can manipulate and change. For example, in the animation I just showed you, I was not updating the scale Y, because if you update the scale Y, then the previous drawn line chart jumps up and down because it needs to adjust to the changing scale Y values. So sometimes it's good to only update one axis. So for the longer term line chart analysis, maybe you only want to update the x-axis and the line chart, and you want to keep the y-axis the same. So in that case, it's pretty easy to achieve. We already have a data array. You can send the whole data array to the scale Y here. So rather than drawing the scale Y from this data, you can actually draw it from a new array. So I can create a static array, and then I can assign the data array to this static array here. So I can do it here. And then while drawing the y-axis, I can actually use the static array. That way the y-axis will not change, whereas the x-axis and the line chart itself are still being drawn from the changing or updating array.